Morning, everybody. This is Dan Schultz. We'll start the meeting in just a few minutes. We'll give folks a little bit longer just to make sure that everybody gets a chance to join. All right, so I think we can go ahead and get going here. This is Dan Schultz with the Division of Water Rights, State Water Board. And we'll go ahead and call the meeting to order here. As we've found in the past, roll call with this many people is pretty difficult. So we'll go ahead and skip roll call. We will move through some updates to start with our drought updates. And the one thing I ask if people have questions or at any time if they're giving updates, please introduce yourself and your affiliation so everybody knows who you are. And yeah, what we'll do is if you have a question at any point or want to make a comment at any point, it'll probably be easiest just to raise your hand, and we'll go ahead and call on folks with their hand raised. And of course, you can also drop any comments or questions in the chat as we go as well during any of our presentations today. So our first item today is to do, one thing before I get going is just a reminder, these meetings are recorded. So please go ahead and keep your devices on mute during the meeting unless you're speaking. And we'll also keep videos off unless you are speaking as well. So we won't do large videos. They take up some of the bandwidth of the meeting and the recording. So I think we can go ahead and jump into drought updates. And since I'm currently talking, I can start for the water board, and we'll go water board to CDFW, and then we'll go over to NIMS, Fish and Wildlife if they're on. Water resources in there too. We'll kind of move through the agencies, then go through other folks that have drought updates as well. So to start with, main drought update I can go ahead and give on at this point is related to the Russian River emergency regulations. These regulations were adopted last July and are primarily focused on surface water curtailments as well as protecting human health and safety water for those that need it, in particular carryover storage and flows coming out of Lake Mendocino to make sure we have enough to get through another potential dry season. So right now in the Russian River, we are not experiencing, we have we do not have shortages right now, so anybody that has a right to divert does have permission to divert. There's no curtailments issued at this point. We are evaluating flows for, starting to evaluate what flows might look like for March. If February does stay dry, we would expect some curtailments will need to be issued in the watershed at that point. We are also at this point starting to evaluate readoption of that emergency regulation. Emergency regulations stay in effect for 1 year and then can be readopted. We're looking at potential modifications and changes to the regulation based on our implementation experience and feedback from stakeholders over the last 6-9 months now that it's been in place. And we're probably looking at doing that a little bit earlier than the 1 year time frame to make sure that any updates that we do move forward with are in place prior to the start of the dry season. So more to come on that as we start to flush some of that information out. That's my main drought update for the Russian. I would turn it over maybe to, let's move maybe to Dan Worth with the Scott Shasta.
Sure. Good morning. This is Dan Worth. I am a senior environmental scientist in the Division of Water Rights, and I've been working on some Scott Shasta drought work over the past several months. We adopted a emergency drought reg in August. It was August 30th of 2021, and the drought reg established some minimum flow requirements for the Scott River and the Shasta River. It does allow for curtailments when the flow requirement is not being met. And it also allows for some exceptions for minimum health and safety and livestock watering needs. At the current moment in time, there are no curtailments in the Shasta River watershed because the flows in the Shasta River at the Wairika gauge exceed the minimum flow requirement that was established in the reg. In the Scott River watershed, flows are currently a little bit under the flow requirement, and so we're kind of in this evaluation phase of whether to reimpose curtailments or wait a day or two until river flows come back up. The temperatures in the Scott River are warming up, and some of the modeling forecast a lot of snow melt and some flow increases. So we're currently evaluating Scott River flows and determining whether we need to reimpose curtailments or whether we can expect some more snow melt. And I think that's all the updates I have for the Scott and the Shasta.
All right, thank you, Dan. And now we'll move over to Nicole Williamson. Are you on for an update on the Bay Delta watershed in general?
Hi, Dan. I am on, but I'm going to turn it over to Lisa Hong to provide a Delta watershed curtailment update.
Great, thank you.
Thanks, Dan and Nicole. So my name is Lisa Hong. I have been working on the Delta watershed curtailment for the last year or so. So our team adopted the emergency regulation for the Delta watershed in August of 2021. Our curtailment method, in its essence, is a big, complex supply and demand comparison. So when there isn't enough water supply to satisfy the demands is when we curtail. We did a monthly curtailment to start in the summer, which means we evaluated monthly supply and monthly demand to see who would be curtailed. During the winter wet season, we moved on to a weekly comparison. And the purpose of that is to allow people to store water in case a storm system comes through, so that we and the diverters can react quickly to it. So since December was really wet, so we lifted curtailments a lot, and we have been seeing a very dry January. So currently curtailments are deepening. and we're seeing curtailments in the Cache, Stony, Puda, Fresno, McCollum, Calaveras, and Chowchilla areas right now. I think similar to the Russian, we are also thinking about evaluating readoption of the emergency regulation that is set to expire in August, and we're continuing to evaluate supply and demand on a weekly basis to determine curtailments until then. That's the update I have.
You're on mute, Dan.
Thank you. Is anybody available to do any updates on Mill and Deer Creek?
Hi, Dan. This is Nicole Williamson. I can cover a Mill and Deer Creek update.
Thank you.
So hi, everyone. I'm Nicole Williamson. I'm a senior environmental scientist in the Division of Water Rights Bay Delta section. For those who aren't familiar with Mill and Deer Creeks, they are tributaries to the Sacramento River located in Tehama County. And these watersheds support multiple self-sustaining natural populations of anadromous salmonids. They are identified as high priority tributaries for the protection and recovery of Central Valley spring run Chinook salmon and California Central Valley steelhead, which are both listed as threatened under the Federal Endangered Species Act. So the State Water Board adopted an emergency regulation for Mill and Deer Creeks in September 2021 for the protection of these threatened fish species, and it became effective on October 4th, 2021. So since October 15th, curtailments have been in effect on Mill and Deer Creeks to achieve flows of 50 CFS to the confluence with the Sacramento River on both tributaries. These flows are needed to provide suitable fish passage conditions throughout the lower watershed. Flows have been above 50 CFS on both creeks since October 15th, and flows of 50 CFS may be required until June. And during the summer months, there is no flow requirement identified under this emergency regulation. As far as more recent updates on Mill and Deer Creeks, State Water Board staff are meeting with stakeholders on Mill and Deer Creeks in February, so this month, to discuss near-term and long-term measures to protect fisheries, including in-stream flow needs, water use efficiency and water conservation measures, habitat improvements, and potential funding sources. And that covers my Mill and Deer Creek update, unless there are any questions.
All right, thank you, Nicole. The one other item that I realized I should give an update on that I don't know if anybody's on to give a more detailed one, but I can just give a quick overview is on January 18th, 2022, water conservation emergency regulations did go into effect. And so those require a number of requirements similar to the 2014 water conservation regulations, include requirements such as turning off decorative water fountains, not irrigating when it's raining or 2 days after rain, shut off nozzles on your water hose, not using water to clean sidewalks and driveways, and avoid overwatering trees, amongst other requirements as well, and water conservation targets. So if anybody's interested, I can drop a link into the chat on more information on that regulation. Any other, at State Water Board, are there any other drought-related updates from any staff? All right, moving on to any regional board updates, drought-related updates. All right, I am hearing none. So let's go ahead and move over to Department of Fish and Wildlife.
I don't know if somebody from headquarters wants to go or if you want regional updates, Dan.
Whoever's ready.
Well, I guess since I spoke up, I'll go ahead and give an update on the Bay Delta region. And then if anybody else wants to follow up, we can do it that way. So I guess first and foremost, we recently hired a drought water rights coordinator, who many of you may know from the Division of Water Rights. We have Shay Richardson now in the Bay Delta region. Hey, Shay.
Hey, thanks, Jesse, for jumping on.
Sure, and I'll just kind of talk a little bit about what we've been up to recently, and then I'll let Shay follow up if she would like to add anything. We have entered into a voluntary drought initiative with National Marine Fisheries Service, and we're doing some targeted outreach in the form of sending letters out in the Russian River watershed. And also this week, we sent out a letter in the Napa River watershed to try to get landowners that might be interested in participating in this program and interested in projects that include things like flow augmentation or water conservation. And so some folks have actually responded to the letters that we sent out in the Russian River watershed. And so we're now following up with those folks and trying to find opportunities to work with them. And that's kind of where we're at with it. I think that's pretty much it. I don't know if anyone from NIMS is on either that wanted to talk a little bit more about things that are happening in other areas in the state. But Shay, was there anything you wanted to add?
No, but I would just add, if anyone, does have any leads for projects like that, please reach out to myself or Jesse. But yeah, thanks, Jesse.
Yeah, and if anybody's interested in those outreach letters that we sent to folks, we can pass those on as well. So.
And is there a website or a link where people can go to get more information on the program? Maybe we could put that in the chat.
Yeah, I think that the websites haven't been updated since the last drought, but I can maybe find something, put it in the chat. That's a good idea.
Okay.
Thanks, Dan.
And then the other thing that and we can follow up, but maybe at the next environmental flows meeting, we can have that as one of the items, and NIMS and CFW can do a presentation on the program to give people more information on what it is, what type of projects you guys are looking for and stuff like that.
Cool, sounds great.
All right, any other updates from CFW headquarters or other regional offices? All right, how about moving over to Department of Water Resources? Any updates there? Okay, hearing none. Moving to any other state agencies that are missed. Okay, let's do National Marine Fisheries Service, please. Okay, hearing none. We'll just, any other federal update? Okay, moving over into just kind of general drought-related updates. If you have any updates you would like to do, go ahead and raise your hand. We'll call on you to keep people from talking over each other. Oh, it looks like Elijah has his hand up.
Yeah, hi everyone. This is Elijah Portugal, and sorry for being a bit late. I can give a quick update on our CDFW CMAST state team. We're a large-scale aquatic monitoring program, and basically we're just gearing up for another field season where we're going to be doing a lot of surface flow monitoring throughout Puck 12s within Northern California. And if folks would like more information about that, please feel free to reach out to me. Thank you.
All right. Looks like someone else has their hand up. Let me try to figure out There we go. Deidre, hopefully I pronounced your name correctly.
Hello, this is Deirdre Desjardins with California Water Research, and my background's in physics and climate science, and I just wanted to say there's a really important paper that's just released. Mike Gettinger is a co-author, but they looked at reference evapotranspiration in watersheds across the West, and they found there's been an increase in evapotranspiration. It's not surprising, but it's kind of stunning. I think it's 50 millimeters, about 3.4 inches across California, saying it's on the order of 10%. I'll get a link to the paper and I'll put it in the watershed, but it indicates that we're having some aerification, not just drought from climate change.
Great, thank you. If there's a link to the paper, maybe you could drop that link in chat so people could access it. Moving on to Conrad.
Hi, thanks. Conrad Fisher with Water Climate Trust. I've been kind of intermittently involved in this process, and I made comments somewhat to this effect. If there is room in this agenda or possibly a side conversation, I think it would be very helpful to resolve some differing opinions about what is legally required to establish an in-stream flow requirement, either interim or permanent, but outside of the emergency context. I've seen them established on small Klamath River tributaries, not yet Scott and Shasta, but whether I talk to water board members, water board lawyers who've been there 30 years, or members of this committee, there's always a slightly different kind of legal opinion. So this is probably the best fish flow science going on anywhere. So it would be great to merge that with what is legally required to actually give water to fish based on the science. So I don't know where that leaves us, but I can explain some of the differing opinions, or maybe a side conversation. I don't know what, but it's kind of been a moving goalpost for about 30 years, and it'd be good to get the water board to say once and for all what is legally required, so the scientists know what they need to do.
So thank you, Conrad, for that comment. We could see with drought going on right now, I don't know how much capacity there is for this conversation to really get this on an agenda. This, in many ways, seems like a much broader conversation and kind of outside the scope of this group. This group is more about a collaboration of folks together and not into signaling out, one agency's authority. We're trying to stay away from State Water Board just implementation. It's not an implementation meeting. This is a forum to get together to discuss the development of in-stream flows, and I just want to make sure that we keep it in that kind of atmosphere. But I do think that there is a space for what you're discussing. It seems like we'll have to think about how to package it together, because it's not just, it seems like you'd like a lot more than just an agenda item update. I believe the board has been clear in the past about what needs to be done to adopt emergency regulations. It sounds like you're wanting something different outside of what we've done, or to adopt regulations and in-stream flows through our standard rulemaking process that we've been working through in a number of areas. It sounds like you're looking for something different. So maybe we can get together offline and try to put together an agenda item that kind of covers the topics that you would like to discuss. And I can see if there's any legal representatives or staff that are available to discuss those at a meeting and give a presentation on it. Does that sound kind of like what you're thinking of, Conrad?
If that's what you think is best, but to me, the underlying purpose of the California Environmental Flows Framework is to make scientific recommendations that can ultimately result in water in rivers for fish. Correct me if I'm wrong, but I mean, that's the ultimate objective of this. If you go in any other regulatory process, whether it's SGMA or California Water Action Plan, or anything that results in water for fish, everyone points back to the CEFF as where the science will come from. So I just think it's important to know if the CEFF is going to result in water for fish and rivers in the form of an in-stream flow requirement, then how precisely? I'm hopeful that level B, if recommendations through level B are framed correctly, can give the water board what they need to establish a recovery flow. So whatever you suggest, I guess I would only differ that I think it is central to the CEFF and not a side project. And I'll be quiet there. Thank you.
There's a number of different pieces here. This is the environmental flows work group. It's not a SEP work group. SEP is a component of one of the products of this work group. So I just want to, this isn't a SEP work group. It's something a little bit broader. But the second part is, a lot of SEP is looking at, like you said, developing the science, and we're going very specifically to regulatory requirements and how to get to the regulatory side, which is fine, but SEP does not cover the process of the regulatory adoption. That's outside of SEP. State Water Board it's an effort that State Water Board's moving through. We have our standard regulatory procedures that we need to follow, and those are not part of this work group or part of SEP. We can give an update as far as to help, like you're saying, help inform this effort, but I'm purposely keeping those two separate because that is not the purpose of this work group. I mean, ultimately, we're looking for improving flows to get flows in the stream for fish through voluntary measures, local cooperative solutions, or other solutions such as regulatory components. But this is not a regulatory meeting. This is an interagency and a much broader meeting for people to get together and discuss in-stream flow development, discuss projects they're working on, have a forum for people to help each other out and provide recommendations and solutions and to give other updates. So I just want to make sure that we keep the meeting in general in the right context and we don't try to steer it into something that's not. And thank you, Nick. Nick oversees for the Water Board a lot of the Monitoring Council efforts. And I don't know if he would like to add anything at this point.
No, I don't think I have much to add, Dan, but I appreciate what your summary is. I mean, right on point. This is a collaborative group that, helps, their primary focus and product was SEF development. And as far as it's still under review by the board, right, Dan? And it's currently in draft form and presented for them, as far as I'm aware. So it's still, that was a product created by this work group in a collaborative fashion. And as the work group under the council, it has to remain non-regulatory in order for that kind of open collaboration and coordination to be successful. If we start bringing in the regulatory pieces, that's where it'll really start to muddy the waters. And that's consistent across the council itself and all those work groups. So while we can talk about the science freely in this sort of venue, we need to be careful, as Dan recommended, is to keep the regulatory pieces and that function outside of the work group itself. We can update on progress of regulation and stuff like that, as Dan has mentioned, but as far as getting into the nitty-gritty of how to create a regulation or how regulation is developed, that's beyond the scope of this work group.
All right, any other drought-related updates from the group? All right, I am hearing none. So we just so happen to be right on time. Moving on to our next agenda item, which is updates on the published Frontier papers. So I will turn it over to, looks like Sarah, you're listed first on the agenda.
Great, thanks, Dan. Good morning, everyone. So Chris and I are going to provide some updates on some of the publications. There's a special issue that has come out in Frontiers in Environmental Science, Freshwater Science, that focuses on a series of papers and topics related to environmental flows in an uncertain future. There's over 20 total articles that are going to be related to environmental flows, both here in California, the Western US, and globally, Australia and other places. 6 of the articles in this publication will be related to SEF in some way. This is all open access. You can see the link here at the top of the slide. You can also just Google Frontiers Environmental Flows Future, and the link will pop up and you can find it. And then if you click on the articles, so the articles are in rolling publication, so they'll come out as they're published. So they're, oh yeah, thanks, Chris. Go ahead, next slide. And so the 6 papers that are going to be relating specifically to SEF are listed here. There's a published paper that gives an overview of SEF and some of the basics. It's a complementary published paper to the draft technical report, which is available to download on the cef.ucdavis.edu website. There's 2 papers that are relating to relationships with flow ecology, looking at flow ecology analysis for stream restoration actions. That's a paper led by Katie Irving. And a second paper looking at linkages between stream alteration and stream condition indices. So specifically things like CSCI, the California Stream Condition Index, and the Algae Stream Condition Index. That's been led by Ryan Peake. There's going to be a paper that should be published shortly that explains the modeling framework behind Section A of SEF. So how did we come up with the predicted functional flow metrics that are available on the TNC website, and sort of a discussion and information and background behind how we modeled those predicted natural functional flow metrics for California. That's the paper that's been led by Ted Grantham. And then the 2 papers that Chris and I are going to give a brief overview today, which are both applications of SEF in 2 different systems. I'm going to be talking about applying SEF in groundwater influence streams, where we have 2 case studies from here in California. And Chris is going to be talking about ecological flow needs or applying SEF down in Southern California. And both of us in both of these papers are focusing on ecological flow criteria. So we've applied Section A and Section B of SEF to look at what those ecological flow criteria might be, given all of the current information and studies that are out there. And so we'll sort of talk through examples of that. Links to all of these papers and additional information on some of the more detailed tech reports and studies that are associated with these case studies can also be found on the cef.ucdavis.edu website. So I'll go first and just provide a brief overview of the groundwater paper, and then Chris will follow up and provide a brief overview of her paper in applying SEF in Southern California, and then we should have some time afterwards just for open questions for both of us. So when we think about functional flows in groundwater influence streams, again, here's the link. If you can go to the next slide, please, Chris. Groundwater influence streams are those where we know groundwater inputs are coming in to help maintain the base flow. And so we typically do not see as much of a gradual decline in base flow through the summer, because there's going to be inputs coming either from shallow subsurface soil, where groundwater is going to be seeping into the stream like a gaining reach, or in some places, particularly up on the North Coast, there's discrete springs and groundwater springs that provide that stream flow or that base flow to the stream. We know that these are incredibly important places for fish habitat, as most of us on this call know. That groundwater is coming from the ground, so it's really moderated in temperature throughout the year. So it's going to be cooler than ambient air temperatures in the summer, warmer in the winter. Very productive streams because of the high nutrients coming through the ground. And so together, this sort of optimal thermal regime with high primary productivity and a relatively stable perennial base flow in the summer can provide really great fish habitat. And as a result, these types of streams, oops, sorry, back one, thanks. As a result, these types of streams provide really great refugia, and they will only become more important as cold water, stable habitat refugia into the future, right, as we get continued climate warming. Okay, next slide, please. So part of the issues we run into with these groundwater influence streams is really not only understanding their surface groundwater connections, but our existing e-flow methodologies and the way that we look at surface flow requirements rarely really accounts for these groundwater effects. So if there's sort of general seepage into the stream from the surrounding area, that might be accounted for in some of the modeling or the way that we look at the geology of the area, for example, but there could be additional discrete sources that are coming in that may not be accounted for, and we don't often have a way in some of our e-flow methodologies to really account for that. Conversely, when we look at groundwater management, our programs tend to focus on the agricultural uses, groundwater pumping, the deeper aquifers, and it's only more recently now with SGMA that we've come into where SGMA is really aiming to partially address these surface groundwater connections such that the groundwater management can't adversely affect surface flows. So there is an important nexus that is starting to happen now between SGMA and e-flow methodologies like SEF that can happen, but it's important that these connections really be accounted for as we do our research moving forward and our analysis moving forward. Next slide, please. So the paper focuses, these are the key objectives of the paper. Again, it really focuses on looking at sections A and B and what type, how best should we consider surface groundwater interactions when we're determining our ecological flow criteria, right? So not moving down into section B where we do the balancing with human uses, but just trying to understand the system and how groundwater is interacting with the system to provide the ecological functionality that we're after. So the paper discusses specifically looking at how can we evaluate these and how might you go about adding in groundwater sources to stream flow in section A, whether that's something that needs to be done if you have information. And then two particular aspects that we address from section B, which is considering channel morphology and how altered channel morphology might affect those surface groundwater interactions. So for example, if we have a highly incised stream, that deep incision could be draining off potentially some of the adjacent shallow groundwater that's nearby, and or it might be limiting the ability for high flows to get out onto the floodplain and recharging the groundwater in that area. And so this is part of section B and SEF. And so we do an assessment looking at that. And then also looking at the effects of water quality. We know from a lot of past studies that groundwater has quite different water quality characteristics in terms of temperature and nutrient than surface water does. And so it's important to take that into account when we're working with groundwater streams. So there's a brief discussion about that. And then in the discussion section of the paper, we do highlight a handful of well-known management actions that stakeholders might want to consider that they would take into account for sustaining these surface groundwater interactions. But again, we don't go into section C specifically. And the case studies that I'm going to be talking about haven't moved into that realm yet in their own case studies as well. Okay, next slide, please. So the two rivers that are highlighted in this paper are the case study that's going on up on the Little Shasta River, as well as the case study from the Lower Cosumnes River. So the Little Shasta River is located up in Northern California. It's a tributary to the main stem Shasta, partially spring-fed. It is not as spring-dominated as some of the tributaries are to the Shasta, but that whole area has really volcanic geology. There's a lot of springs, a lot of really incredible groundwater sources up there. And there are some springs that feed into the Little Shasta River, particularly in the higher reaches. Great coho and Chinook habitat historically in these areas due to the groundwater inputs from having this cold, nutrient-rich water that comes into the streams. So historically, there were large, extensive wetlands throughout the basin and in the Shasta in general. There's still existing groundwater dependent ecosystems that are there that are supported by some of the shallow groundwater and springs that are there. But like many places in California, the Shasta has been impacted from agricultural diversions and grazing. And a lot of the springs in the Little Shasta are currently fully diverted for agricultural use. So the Lower Cosumnes, we focused on looking at where the Cosumnes River comes out of the Sierra Nevada in the Central Valley out into the Central Valley floodplain area. The base flow here is really supported by a complex of these shallow perched aquifers in addition to the larger deep aquifer that's down underlying the Central Valley. And the Cosumnes supports, again, like most Central Valley streams, historically supported a diverse native species assemblage. You had anadromous fish, you had resident native fish that used the floodplain, extensively connected to the floodplain for spawning. There's large riparian forests and GDEs down in the bottom of the basin. But like all the Central Valley streams, it's been heavily impacted by agricultural use, development, and predominantly groundwater pumping. Okay, next slide, please. Thanks. So we looked at 3 locations of interest in the Little Shasta River, following through section A. I'm going to talk today a little bit primarily about LOI 3. So the Little Shasta drains into the main stem Shasta, which you can see down there on the lower left side of the slide. Location 3 is located where the Little Shasta flows out of the mountains and the foothills. It goes through a small foothill reach, and then it flows out across kind of a valley baseland there. And those green shaded polygons are GEs, or groundwater dependent ecosystems, that are remnant from the historic wetlands that were there and some of the wetland areas that are there. So we picked 3 locations where we could look at where the water comes out of the foothills, the upper bottomlands reach there at location 2, and then down by the confluence at location 1. And again, the paper is just highlighting aspects about the larger study that's going on in Little Shasta. And so we'll focus primarily on location 3, which you can see in this map is downstream of a series of discrete springs that are known to have historically input water down into the Shasta. So next slide, please. On the Lower Cosumnes, we picked 2 locations of interest that were adjacent to the gauges. The historic McConnell gauge that was located so again, the watershed's coming out of the mountains down onto the Central Valley floor there. The old McConnell gauge is kind of in the upper part of that Lower Cosumnes Basin, and then the current Michigan Bar gauge, which is down closer to where the Cosumnes River meets the Delta. And again, these 2 locations had good gauge data and were also representative of sort of stream channel and floodplain conditions in both locations. Okay, next slide, please. So again, the questions that we were focusing on in the paper were specific to, in section A, do the natural functional flow metrics that have been modeled for each of these locations of interest reflect the groundwater contributions? Is there a way for us to evaluate that? And do we need to take that into account when we're considering what these natural functional flow metrics should be as ecological flow criteria? Secondly, per section B, we asked questions relating to channel incision or channel morphology conditions that might, again, alter whether or not these metrics would provide the functionality that we expect, or do we need to adjust these metrics in some way to account for the altered channel condition in order to make sure that we're achieving the ecological functions that we want. And so we looked at both channel morphology and water quality conditions. And here's just the example from the Little Shasta River up at that foothills reach. For that location, these would be the predicted metrics that you could just go get straight from the website for the TNC website. These are the modeled natural functional flow metrics that are available statewide. And the question is, will these provide the functions in the system, or through the process of section B, do we need to adjust a couple of these components where these types of ranges might not provide the ecological functions that we're after? Okay, next slide, please. And so here, so for section A, looking at groundwater. So for the Little Shasta in particular, there's not a huge amount of data available in terms of how much the spring contributions are currently producing, but there is some reports from almost 100 years ago now that do show and provide estimates of volumes from some of the discrete springs in the upper location. Our LOI 3 is located at the base of Table Rock there, just a little ways downstream of that Cold Springs. So one thing that we did is we evaluated, there was some gauge data at that LOI 3 location, and we compared what the functional flow metrics were calculated at that gauge location with what the predicted functional flow metrics would be. And interestingly, they came out as the same. And we know that that current gauge does have the springs diverted, so the spring flows were not being accounted for in the flows at that gauge location. And that those values that were calculated matched the predicted functional flow values very closely that we had from the model. So what that did is that gave us an indication that these springs were actually not necessarily being well accounted for in our predicted functional flow metrics. And so we would then need to potentially add that 10 CFS of discrete spring flow into our base flows, because historically that would have been more of the condition that the species would evolve to. And so based on the current information that we have at the time available for this study, that would be a choice that we made to then increase the base flow and account for that additional 10 CFS of spring flow that was not accounted for in the modeling. On the Lower Cosumnes River, when we looked at it, we did a pretty extensive, collectively the larger group working on this did an extensive literature review in terms of trying to look at the data that's available for the Lower Cosumnes. There are potentially some base flow contributions from the perched aquifers that might be occurring in particular reaches of the Lower Cosumnes. But to quantify those numbers in such a way that we would then be able to evaluate how and whether or not the models might be accounting for that base flow was really just not something that was able to be done without more specific study to quantify those numbers. So we chose at this time then to leave the predicted functional flow metrics as is and to not add additional groundwater contributions until further study could be done. Okay, next slide, please. And so really quickly then with channel incision, we looked at the Little Shasta. There's really no impact of floodplain connectivity or altered morphology in the upper foothills reach. There's a little bit of incision down in the bottomlands reach, but not enough to really limit that 2-year flood lateral connectivity or to limit those peak flows. So the natural high flows are able to get out on the floodplain. And so we then felt after doing that analysis that no additional adjustments to the metrics were going to be needed. Conversely, on the Lower Cosumnes, the middle reaches of the Lower Cosumnes in particular are quite heavily incised. And so we looked at some results and data that had been specifically gathered by U.S. Fish and Wildlife Service to look at what types of flows are needed to get out on the floodplain. And we found that the natural range of peak flows, particularly the 2-year peak magnitude, is not getting out on the floodplain. And so we might need to raise that and increase that metrics to allow for higher flows to get out onto the floodplain. So if we don't change the channel conditions and the current channel morphology, you would need a higher peak flow to get out onto the floodplain to provide those groundwater recharge and some of the other functionality, and that can to help create that connection with the shallow groundwater in the floodplain. Additionally, there was some work, some of the upper reaches have been impacted with sedimentation and sedimentation effects. And so there was additional study looking at whether some of the minimum flows that were predicted for the fall pulse would be adequate to provide fish passage. And so what we did there is we just increased the minimum of the range of fall pulse flows needed to make sure that that fish passage can occur up in that area where the channel morphology is altered. Okay, next slide, please. And then in terms of water quality, again, so the springs provide this really highly productive cool water up in the Little Shasta. If those springs are diverted and water is added back, was chosen to be added back into the channel from the agricultural runoff, it might provide a poorer, warmer quality of water and not as suitable for fish habitat. So, but we found that you don't necessarily need to make adjustments to the base flow. So for example, the base flow, if it's cool, you don't need to add more water to try to cool down the water. As long as if it's spring flow that's coming in. So things like temperature considerations or water quality considerations, if the spring flow is added to the channel, that would provide really great water quality and we wouldn't need to adjust the metrics any further. On the lower Cosumnes, there are some nutrients and pollutants that do come into the system. There, again, there's some additional great studies that have shown this that we reviewed. But those fall pulse flows as they naturally occur and the high winter peak flows as they naturally occur do a great job of flushing out the system. So again, as long as there's just monitoring, there really isn't a need to adjust the metrics to account for issues where water quality might be an issue. Okay, next slide, please. And so when you put this together, essentially what the conclusions were that we found was that in Section A for Little Shasta, we did decide to add 10 CFS of the spring contributions. And you can see here in the table that you've got the natural functional flow metrics that came off of the predicted models that are on the TNC website, and then the updated metrics working through the process in Section B, what was adjusted. So we increased 10 CFS to the base flow requirements there, so both the median and the ranges that are highlighted in the blue boxes, but no further adjustments based on channel incision or water quality were made. We just continue to monitor, and again, if the spring flow is what's being provided for a lot of that base flow, that's going to provide great water quality, so we don't need to make further adjustments to try to account for flushing or temperatures. Next slide, please. And then for the lower Cosumnes River, this is down at the Michigan Bar Gauge, for example, again, a similar table setup. You can see these are the functional flow metrics that were predicted for that site. And the only adjustments we really decided to make at this time, so we don't make adjustments for groundwater contributions because we really don't have the information to quantify what those perch aquifers might be adding to the system. So at this point in time, we don't make adjustments for that. But we do make adjustments based on channel morphology. And you can see that specifically the 2-year peak flow magnitude needs to be increased in order to get out onto the floodplain more effectively and yeah, under current channel conditions. And similarly, we increased the minimum of the fall pulse magnitude up to 180 CFS so that we know that it can allow for fish passage in those sedimented and altered areas up at the top of the reaches. And then for water quality, we just continue to monitor. So this is sort of the results of walking through Section A and Section B and taking into account those aspects of SEF that relate to these surface groundwater conditions. And so next slide, please. So just to wrap up, a couple of the management actions that we highlight in the discussion section that could be considered in Section C by stakeholders was that the importance of maintaining these spring and groundwater contributions to really help support the high water quality. So we might want to support funding for supplemental sources of water for agriculture and really keep that high quality spring flow and use that as the base flow in the stream rather than other off-channel diversions or surface water flow that's coming from other locations such as ag-return flow. And we might want to do some restore the riparian habitat to really help, do some shading and providing that high quality water. And in terms of if one of our goals is to increase groundwater levels to help maintain that surface groundwater connection, we can consider things like floodplain reconnection, riparian recharge, where you're really getting out on the floodplain and being able to recharge the adjacent groundwater for the wetlands, the GBEs, those perched aquifers that are adjacent to the lower Cosumnes, those types of things. And we might consider relocating potential shallow wells that would be adjacent to these riparian areas. So, so that's the summary of the paper. It's available and open online. And with that, I'll wrap up and turn it over to Chris. And then we'll take questions after. Thank you very much.
An appointment is scheduled. Okay. Hi, I'm Chris Taniguchi-Kwan from Southern California Coastal Water Research Project. Today I'm going to be giving you an overview of the CEF application in Southern California that was focused on developing ecological flow needs in an altered region of South Orange County, California. I do want to note that this work is part of a larger study called the South Orange County Flow Ecology Study that was funded by the County of Orange Public Works. And this case study application was also funded by the Wildlife Conservation Board Prop 1 Stream Flow Enhancement Program. Okay, so this CEF application is a little different than some of the more traditional in-stream flow studies. We're focused on a highly modified urban watershed. We're establishing reference-based flows may be a challenge for multiple reasons. We have altered stream channel conditions, so we have stream channel erosion. We also have flows that may be far from reference, so going back to kind of a reference condition may be difficult to achieve. And then in some areas, we have augmented flows that may be supporting novel ecosystems that may not have been naturally there under a drier natural condition. For example, some dense riparian areas that are observed in some of the more naturally intermittent or dry stream reaches. We're also working in a region where flow modifications are primarily from diffuse non-point sources like urban runoff, irrigation overspray. So we aren't working in a typical system where we have one knob to turn like a dam regulated system or a stream with a major diversion point. And so this is kind of spread out and diffuse. So different types of flow management actions need to be taken place in this area. And then lastly, water conservation may or may not be in conflict with our ecological flow criteria. So it's really important for us to understand where, when, and in what direction the flows are currently altered compared to our ecological flow needs in this area. And so in terms of the main objectives for this paper, we wanted to provide a demonstration of CEF in a highly altered system. So we lay out kind of the process and the methods of how we implemented CEF in South Orange County. We focus on one location of interest with the goal of implementing CEF across the entire region, so multiple different stream reaches. We also wanted to develop ecological flow criteria that considered altered physical habitat, so stream channel incision and widening, and flow criteria that are supportive of key ecological management objectives identified from our stakeholders. And then lastly, we provide an example of how changes to the channel form can help achieve ecological flow criteria that we've developed in CEF Section B. So this is one consideration of CEF Section C, where we think about non-flow management actions that could be implemented in addition to flow management actions. And as Sarah mentioned, this case study is primarily focused on sections A and B to develop ecological flow needs. And we have not yet gone to the point of developing environmental flow regulation recommendations through Section C for this study. In terms of our ecological management objectives, we've had multiple stakeholder meetings to try to identify these key goals for the region, starting more broadly and then going a little bit more narrow. So the first one is to improve stream flow conditions to benefit overall stream health. Another goal for the region is to reduce unnatural flows that don't provide a benefit to the environment. So flows that may favor invasive species, for example. And then more specifically, we are looking at flows to help provide habitat to support federally endangered least Bell's vireo. For this study, we focus on black willow as a surrogate for riparian habitat for these federally listed birds. And then there's also a desire to restore habitat for native fish populations in this region. So we focus on Uro chub as one of our indicator species. I do want to note that Uro chub is not currently observed in the study reach. but there are desires to rehabilitate stream conditions to be more conducive for native fish populations. And so we included that in our Section B analysis. So as I mentioned earlier, our study area is the South Orange County Watershed Management Area. So you can see all the different watersheds on this slide here. Our main focus for the paper is on the Aliso Creek watershed in purple. This is a highly urbanized watershed, and we're focusing on this lower Aliso Creek reach, this star right here on this slide, because it's one of the last remaining soft bottom reaches in this highly urbanized watershed, and it does provide critical habitat for this region. I do want to note that altered hydrology and channel erosion have been identified as the highest priority water quality conditions through the Water Quality Improvement Plan, and so this is one of the special studies to help inform future flow management targets and different recommendations for restoration. And so these are the different sections in CEF on the left, so sections A, B, and C. And the slide here kind of maps some of the key methods or different points that we highlighted in the paper. Today, I'm not going to go into all the details of all of these points, but I am going to focus on a couple of key points for each of the different sections. So in section A, it's all about identifying the natural range of flow metrics and identifying if there are limiting factors that would alter the relationship between flow and ecology, and do we need to actually take a closer look at some flow components through section B. And then in section B, we used, you can use a variety of different methods to develop your ecological flow criteria. In this study, we used two different examples. So I'm going to illustrate the two different approaches that we used for Aroa chub and for willow. And then lastly, in section C, we did an alteration assessment, and we also looked at if we can change the channel form through stream channel restoration, for example, how would that affect the ecological flow criteria or the ecological flow needs in this region? And so through section A, we've identified if there were potential limiting factors that could limit the effectiveness of the natural range of flows in supporting ecosystem functions. So for this study, we identified altered channel morphology or channel widening and instability as a key limiting factor that could impact the wet and the dry season base flow, and also this spring flow recession from supporting these desired functions. So for example, if you can imagine a widened stream channel, that could mean that we need a larger spring flow recession to actually get out of that channel and inundate the floodplain, similar to what Sarah was talking about in her incised channel. So if we want to support functions that are associated with floodplain inundation, like seed dispersal, we need to consider altered channel morphology when developing our ecological flow criteria in section B. And so these are the three flow components that we are focusing in on for section B. And so, as I mentioned earlier, there's multiple different methods to developing ecological flow criteria. So I'm going to highlight two different methods. So this is for Aroa chub. We developed a conceptual model that links the functional flow components that we're evaluating. So in this case, the wet and the dry season base flow. We used a hydraulic model to evaluate hydraulic conditions across a range of flows, and that'll give us information about our physical habitat, the depth and velocity. This is a way that we can incorporate our altered channel morphology in our ecological flow criteria development. And then we applied habitat suitability curves that relate depth and velocity to our ecological response, in this case, survival of Aroa chub. And so for this, for Aroa chub, we developed two different suitability curves that were based on existing data collected by Wolf et al. 2017. And so you can see These different curves relate our physical habitat characteristics, so depth and velocity, to the probability of occurrence for arroyo chub survival. And so we can use these curves to identify an optimal flow range to maximize habitat suitability or habitat availability in our study area. So in contrast, so this is the conceptual model for Willow. So again, we linked our functional flow components that we're evaluating, the wet and the dry season base flow and the spring recession flows. We model that, the hydraulics to evaluate the physical habitat characteristics. In this case, we're looking at depth or inundation of the overbanks and inside of the channel. And then we relate that to habitat suitability for willow seedling and adult. And then that is related to our ecological response, which is growth and adult survival. And so in contrast to the arroyo chub method, we actually developed habitat suitability rules that link the different life stages to the functional flow metrics that we're evaluating. And then we developed rules that are related to certain stream functions that we want to support. And so we developed rules for the lower and the upper limit. So for example, if we think about the spring recession flow again, we want to make sure that the lower limit of our flow criteria is a discharge that will actually get out and inundate the floodplain. So in this case, we said the flow that is associated with 10 centimeter inundation in the overbanks, that'll allow for seed dispersal and also to provide adequate soil moisture before the dry season starts. And so we can use these different flow ecology relationships to ultimately develop ecological flow criteria in section B. So what you see here is a table that shows the natural range of flow metrics in this column. And then we have our adjusted ecological flow criteria for willow and arroyo chub. And the bolded values represent the adjusted metric values from our habitat suitability relationships. I do want to point out that for the wet and the dry season base flow magnitude, you might notice that the optimal flow range is really high. It's greater than 120 CFS, which is much larger than our 2-year peak flow magnitude. And this was primarily due to the fact that we have an enlarged channel, so it takes a much larger flow to actually get the depths necessary to support arroyo chub. So I'm going to circle back on that in a little bit. And we also compared our current flow ranges to our reference expectations, and then also to the ecological flow criteria we've developed for our species. And so this is an example of the spring recession flow magnitude, where you can see that the current flow is slightly augmented. So it's in the upper range of the spring recession, the natural range of the spring recession. And then our willow ecological flow criteria falls kind of in the mid range. And so I just wanted to illustrate that we use the floodplain, the flow associated with floodplain inundation to adjust our lower limit for our willow ecological flow criteria. So you could see if we were to use a reference-based flow criteria, if the flows fell below this line, then the functions that are associated with floodplain inundation may not actually be supported in this case. We did the same type of comparison for both the dry and the wet season base flow. So you're seeing a similar plot here showing the current range of flows. You can see that the flows are currently augmented compared to the reference range. And then this is our willow flow range for adult survival. And then our arroyo chub flow range, as I mentioned earlier, it's extremely high. It's way higher than what we currently observed in the dry season. And so one of the reasons is because the existing channel is too wide to provide suitable depths for arroyo chub. So you can imagine that the flow is spread out. And so the depth in the channel is actually much narrower than what it would have been under natural conditions. So we asked the question in section C, can changes to the channel morphology be made to provide more achievable ecological flows? So in other words, can we alter the channel morphology to provide a more realistic flow target in this example? So we looked at an example channel design with the main channel being much narrower and adding in an inset floodplain. And so we developed our adjusted ecological flow criteria under this alternative channel. So for Willow, it's about the same under both channel scenarios. However, for Arroyo Chub, you can see that the ecological flow needs are much closer to, I guess, reality or to the current flows. This was just meant to provide an illustrative example of how you can play around with different management scenarios to see how changes to the channel can impact the flows needed to support Arroyo Chub. And so if we did want to get ecological flow criteria that was maybe closer to current conditions or that overlapped with our flow range for Willow, for example, additional alterations to the channel may be needed, like altering the slope of the reach or the roughness, or providing, small side channel pools, low flow refugia, and things like that. So again, this wasn't meant to be an extensive channel restoration analysis, but just an illustrative example of things that you can explore in section C. So overall, these are a couple of the lessons learned while implementing CEF. CEF provides flexible guidance. As I mentioned earlier, there's multiple different approaches that can be implemented in section B. We provided 2 examples. Our example for Arroyo Chub was really similar to traditional methods like PHAB-SIM. And then our example with Willow provides kind of a different example of developing rule sets that are linked to our altered channel morphology and the ecological response. And then also in highly altered systems, it's really important to consider these mediating factors like channel alteration, water quality impairments, or things like stream temperature when developing ecological flow criteria, because these mediating factors alter the relationship between flow and ecology. So those reference ranges may not be suitable under these altered conditions. Another point is that non-flow management actions, in addition to flow management, may be necessary to achieve ecological flow criteria in some of these highly altered and constrained systems. And then lastly, CEF can be used to prioritize areas and to inform channel restoration designs. This CEF paper, application paper, is focused on just one aspect of our larger study in South OC. And so this provides, one way that CEF can be used outside of developing, specific flow management recommendations, for example. And so our paper was provisionally accepted, so the abstract is available online, but the actual full article is still in press, so it should be available within the next couple of weeks. So you can check back on this link. If you have any questions, feel free to email me, or we can stop now and open up the floor for questions for both Sarah and I.
All right, it looks like Norman Johns has his hand up first.
Hi, thanks. I've got a question for you on the Southern California example. I really liked your conclusion that you could get a lot more bang for your buck with limited flows by modifying the channel. But I guess I have to ask sort of a background question. I normally hear about channels being incised outside of their natural appearance. So in this case, how was the channel morphology that you're dealing with in the current state, like extra wide, due to an unnatural flow characteristic and modification, or is that more or less still the original natural channel?
No, yeah, that's a really great question. So in this area, especially in the reaches of Lower Aliso Creek, the channel is both incised and widened depending on where you are along the reach. And it's primarily due to the upstream urbanization. So these are unnatural flows and flashier peak flows that have caused the channel to enlarge.
That's the case I normally hear about. Yes, thank you.
Mm-hmm.
Jenny Ta?
Hi, thanks so much for sharing these case studies. I'm really looking forward to digging into these papers. I have a question for Sarah about the Little Shasta and the Lower Cosumnes case studies. I'm curious how the step 1 of section A was, I guess, conducted in terms of like how were the ecological management goals defined for these case studies?
Yeah, I was realizing when Chris started that she really should have gone before me because she did a much better job of reminding everybody what the steps of SEF were in her presentation. So so the paper really focuses on highlighting the aspects of the SEF application that relate to groundwater, but in the fuller SEF kind of analyses so the Little Shasta is still currently ongoing and the Lower Cosumnes is finished, we do highlight in step 1 those ecological management goals. And in both cases for Little Shasta and the Lower Cosumnes, they're primarily to support the broad suite of ecological functions that the rivers did historically provide. So that diverse native species complex, fish species assemblage, as well as riparian habitat and supporting the groundwater dependent ecosystems or the GDEs that are currently in both systems. So those would be the primary ecological management goals that were delineated in step 1. And then step 2, we go on, we pull from the TNC website to get those reference-based or predicted natural functional flow metrics, and then move forward with the steps, evaluating whether or not the groundwater contributions and or the additional channel morphology, non-flow factors that you evaluate in section B need to be studied. Does that answer your question, Jenny?
Yeah, thanks, Sarah. And I'm curious, like, who had to be involved to define those goals?
It's a great question. So, and I am remiss because I forgot to mention the funders. So the Lower Cosumnes was funded by American River Conservancy, TNC, Cosumnes Coalition, and then and WCB is partially funding the Little Shasta case study. So if we have a larger stakeholder group that can come in from the very beginning, which is ideal, then you would collectively be looking at those ecological management goals together. In this case, it was the stakeholders that were part of the funding in the original project that initially defined that. But as we move into section C for both case studies, if we can bring in more stakeholders, then that evaluation can be revisited. But in both cases, we took a very broad scope to the natural riparian and aquatics assemblages and systems that are there naturally and highlight those as our ecological functions. So this was not about like a study for coho or a study for Chinook salmon, right? Like that. We looked at the suite of the species and the assemblages that are there and wanting to support that assemblage more fully as our ecological goals.
Great. Thanks so much, Sarah.
Yeah, thanks, Jenny.
Next question is Ben Pitterly.
Yeah, hi, thank you. This is Ben Pitterly. I'm representing Santa Barbara Channel Keeper. And, you know, this is really important work, and I appreciate so much hearing about the other regions where this framework's been applied. In the watershed that I represent, the Ventura River, I did want to share some concerns that our group and some other community groups had about application of the SEF approach to develop watershed criteria. And specifically, we have concerns with how the natural dry season base flows were predicted. So we live in a watershed that's highly impacted by surface groundwater connectivity and the existence of significant groundwater pumping, and limited gauge data exists. Natural dry season base flow predictions, they largely utilized a gauge that had data going back to 1967, but our watershed was already highly impacted by groundwater pumping, you know, through that period. So surface and groundwater interactions, unfortunately weren't really accounted for in the criteria report. And as a result, the dry season base flows that were published were really grossly underpredicted, we believe. So, an attempt was made to account for pumping by using a synthetic gauge, quote unquote, that added water from one of the surface diversions back into the model. But even with that adjustment, that's just one surface diversion amongst, entire watershed full of wells that are continuously pumping groundwater throughout the year. So, in the real world of just politics, right, that we're working within, publication of modeled results that are labeled as, quote unquote, natural without a real robust discussion of the model limitations, just we're concerned can be at times can be somewhat detrimental, because those numbers are being used by water purveyors to promote the notion that in the real world, the functional flow criteria are simply unrealistic and that they can't be achieved. And when we get to discussions that are pending, right, about and legal negotiations that will be occurring in the future surrounding the issue of balancing beneficial uses, these characterizations that are made using published data, they really matter, and they make a difference in terms of what minimum flow requirements will actually be, what the outcome of these processes will be. So it's encouraging seeing how much work's been done on this. We support these efforts. We hope that this group continues to refine the approach specifically to address regions like ours where limited data exists to allow for real ground truthing of pumping related impacts on surface flows. And at a minimum, we hope that future reports that are released by the department or others that utilize the SUF approach can include robust language that at least acknowledges various limitations and assumptions that go into the model. So thanks so much.
Mm-hmm. Yeah, thanks, Ben, for the comment. I might just offer a little bit of clarification, and perhaps if Ted's on the line, he might want to jump in too. So the predicted natural metrics, functional flow metrics, are not based on just a local single gauge that is nearby, right? They're based on statewide models that incorporate all of the reference gauge data that's available. So it's not quite accurate to say that they don't account for base water, or that they're only accounting for the single local gauge that's nearby. We can use the local gauge to do an evaluation of what the modeled predictions are saying for our area, and that is similar to what we did up at the Little Shasta, right? But to the degree that those modeled predictions are accounting for natural base flow inputs that might be related to geology, which are one of the parameters that get included in those statewide models, versus where we have discrete spring sources like what we saw in the Little Shasta, an evaluation of that gives us more information about whether or not those predictions are really accounting for the groundwater. So I just want to highlight that, because I want to make sure that there's no misunderstanding about where those predictions are coming from. And I'll pause a moment, and then maybe Ted could jump in if he'd like to add on the modeling. But regardless, like for example, what we found in the Little Shasta is following that evaluation where we felt that those discrete spring sources were not being accounted for necessarily, then we can add them in. And there's that flexibility to do that. And it might require further study with these surface, like a local surface groundwater model, to really account for those contributions. So for example, that's a little bit what we found in the lower Cosumnes. It may be that the natural predictions are doing a good job of supplying that base flow value, but because of the nature of the perched aquifers that are there, we might need additional study there to really make sure to determine whether or not those predictions are there. So I hear your point. It's well taken. That's partly what we were trying to bring up and address in the groundwater model. But I just want to make sure that we're being very clear about the modeling that's behind it. And I don't know, Ted, if you're here, if you want to pop in.
Yeah, no, Sarah, you did a great job of identifying some of the sort of background of the model and how it's structured, and we fully are aware of some of the limitations of the model in predicting base flows and groundwater influence systems, which is sort of why we highlighted the work in the Shasta and Cosumnes for that very reason, to demonstrate that the SUF approach overall can accommodate those situations where the natural flow modeled predictions are not are not working. And yeah, no, I mean, I really appreciate your comment. And I think in the publication that we have coming out and elsewhere, we have, I think, been done as good a job as we can to highlight both the limitations and the applications of this of this model. And I think there are certainly going to be issues where our predictions at the local level might there might be disagreements over whether or not those are reflect reality, and there may be other locally developed models that you might trust more. In many systems, you might not have any models, and that's really what the primary goal of this work was to sort of alleviate the need for every watershed group or every water district to develop their own model, to even start the process of thinking about environmental flow requirements. And so there's a trade-off there that we're trying to negotiate. But definitely appreciate the comment and happy to discuss more. I guess the last comment I'll make is that we are sort of have an ongoing effort underway to sort of update and improve the models where we can, with a particular emphasis on base flow. So hopefully in the coming years, we will have perhaps estimates that are we consider to be more reliable, more useful for some of these different applications. Thanks.
Yeah, thanks, Ted.
Great. So I think we're running a little light on, or short on time, but I think we have two more folks with hands up. So let's go to Nick Joslin.
Oh, muted.
My name is Nick Joslin. I'm with the Mount Shasta Bioregional Ecology Center and a 5th generation resident from the Little Shasta River. My family ranched there for a long time, and so I have a special part in my heart for the area. I luckily left the ranch and got a geology degree, and I come back to the area with a deep desire to see something good come out of the area. So I appreciate the effort you're putting into the science. I'm new to understanding this environmental flow framework area or dialogue, and I understand it's kind of pilot projects are going through right now. As a scientist, I really can't appreciate kind of trying to keep yourself out of the politics of the area. But it's, that's the divide, and I think it's where science has kind of remained sort of hindered. At the end of your presentation on the Little Shasta, you had mentioned Section C, and that's kind of the area where in this region, the Shasta River, the Little Shasta River, people have been trying to do a Section C type dialogue for decades now, and it has gone nowhere. And so while we do understand that the shortcomings of this stream being productive are ag, then we turn over to Section C and say, what does ag need? Well, what ag needs in that area is all the water they can get, and that's how it's gone historically. So, talking about getting the spring contributions into the streams is exactly the same dialogue we're having on the main stem of the Shasta, where much of the cold water spring flow is impounded and used for agriculture and returned to the river warm. I'm just trying to reckon how that handoff occurs. And I know there was earlier dialogue about whether this, is a regulatory structure we're talking about, if this is a science-based dialogue. But at that point where we hand off good science that shows, the streams are in jeopardy and the reasons are diversion of water for quote beneficial use, how do we go forward at that point? Because we're stuck under the umbrella of water rights, historic use of water at a much wetter time. I mean, this area is essentially a desert. It gets almost no rainfall, and it's increasingly getting less snowfall. I appreciate the idea that spring flow into streams might have greater resilience during climate change, but I don't think they're as resilient as people believe. Goose Nest is not a giant mountain like Mount Shasta. It has no glaciers. That is the source of the Little Shasta River, and cows are in the spring on Forest Service land, free ranging and degrading the water quality as it pops out of the ground. And so anyway, I don't know if I have a question per se, but I do appreciate that you're doing good science. I'm just having a hard time seeing how we move into Part C, Section C, and stand up for the science. Thank you.
Yeah, thanks. I appreciate your comment, and I would just add that one of the things we're hoping with SEF, and part of the reason that this collective technical team and group and agencies have come together, is to help call out and make a lot of those decisions transparent, right? So if Section A and Section B are the science and where we're putting the science together, and Section C then becomes that stakeholder discussion. And so the hope is that by bringing people together to at least have a more collective, similar set of information that they can talk about that comes out of Section A and B, that will help foster some open and transparent discussions. But in all cases, and maybe this is something that maybe this environmental flows technical working group, might be interested in discussing. How do we help each other move from Section B to Section C? What are different examples that people are using around the state? And maybe that's a future topic of discussion where people can share their stories of how they moved into Section C. What did they learn from the process of stakeholder engagement in Section C? And maybe that'll spur some new ideas. But yeah, so just my only thought on that in terms of moving forward with that. Thank you.
Okay, so I will just add, I'll drop a link in as well for the California Water Action Plan effort between State Water Board and DFW, which is more of a formal regulatory effort that's happening, so that folks can sign up for notifications and get more information about that effort as well, since I know there's interest there, and that is there is a effort going on with a platform to discuss some of those regulatory concerns and needs.
Thanks,
our
Dan.
last comment on this, you bet. Our last comment on this item will be from, I'm going to say it wrong again, I know, but Deidre Desjardins. Apologize again.
Yeah, this is Deirdre Desjardins, and I did research in complex systems theory for several years at the Santa Fe Institute, and I started looking at the processes of collaboration and how they work and they don't work. And one of the things that's really coming out is, and I dropped a link, there's a concept in psychology called tribal bias. It's a nearly ineradicable element of human nature, and it causes predictable cognitive biases in groups. And when you have a collaborative group like this, there's a set of cognitive biases from the water diverters. There's a set of cognitive biases from other folks. And unless the collaborative process is structured carefully to protect the environmental folks who are generally representing the public trust, and they're generally much less well-funded, and they're not, people unconsciously within these groups tend to gravitate towards power, and the power is always in the water diverters. And so you have to be really careful if you have a collaborative process like this, that you're not and you're having collaboratively setting ecological goals, that you're still meeting the state law. And and it does say in state law that the longstanding constitutional principle of reasonable use in the public trust doctrine shall be the foundation of state water management policy. So when Conrad Fisher said, there's a legal aspect, it's just, you really have to ensure that the public trust is taken into account and it isn't baked into these scientific analyses before they even get there. Because if your stakeholder group isn't adequately representative, or if it's skewed in a way that the minority voices from environmental folks, like the folks who just spoke out and said, hey, what about this? You're going to have a problem. So I'll put a link here, and this is an active area that I'm working on. Thank you.
All right, thank you. So at this point, I think we'll move on to our next agenda item. I wasn't sure, was there another are we on the update on CFW SEP trainings, or was there one more presentation?
No, we're done, Dan.
Okay, great. So Bronwyn, are you on?
I'm actually going to give the update today, Dan. My name is Alyssa Obister. I'm a senior environmental scientist in CDFW's in-stream flow program in headquarters. Last month, Bronwyn and I trained over 100 CDFW staff in functional flows and the California Environmental Flows Framework. We held these trainings virtually for each CDFW region, and we had good representation from folks across the state and from various disciplines. We trained staff on the functional flows approach, SEF, and key tools and products to come out of the framework, such as the modeled functional flow metrics. And our goal with these trainings was to increase knowledge and build a broader understanding of functional flows and SEF within the department. We got a lot of positive feedback. Staff were really engaged, and based on feedback that we've received, we're hoping to hold a more technical training in the future to dive into the tools in a little bit more detail. And if you're from CDFW and would like to be included in future trainings and correspondence, I will include my email in the chat, and you can feel free to contact me. Thanks.
Thank you, Alyssa. So let's see, our next item is an update on the SEF workshop for SRF. Is someone from the tech team gonna go for that? Ted, it looks like you jumped on.
Yeah, thanks, Dan. Yeah, so I just wanted to let folks on the call know that this April at the Salmonid Restoration Federation annual meeting in Santa Cruz, California, we will be holding a SEF workshop on Wednesday, April 20th. And this will be a half-day workshop that will sort of get a little bit more into the weeds. We'll provide an overview of SEF, some of the background scientific concepts, the tools we developed. We'll probably do a deeper dive on some of the case study applications of the environmental flows framework, and provide plenty of time for discussion and question and answer. And so if you're interested in learning more about the environmental flows framework, you are welcome to register. Registration is open and open to all. I know it'll be maybe perhaps a challenge for some of our agency partners to attend given travel restrictions, but if you're interested and able, we encourage you all to attend.
Great, thank you, Ted. I dropped a link to the environmental flows framework item at the SRF conference. So if you follow that link, you'll go straight to the page that discusses this specific workshop, and then you can get to the rest of the conference agenda and everything else in registration from there. So let's see, at this point, we'll open up the floor for any other updates. It looks like Kimberly Burr, you have your hand up.
Yeah, hi Daniel, can you hear me?
Yes, we can.
Okay, I just wanted to thank you guys so much for all your hard work and these incredible case studies, because I think they are very informative and show kind of where we're at with all this and where we need to go. So incredible work, important science. So I just wanted to thank you guys so much for doing it. And I just also wanted to say that I have put out a call for technical assistance on Green Valley Creek over here in Sonoma County, because I want to work to get a, I don't know what you would call it, stream flow analysis of the creek, and what are the environmental flows. I guess, what does the model say about environmental flows on Green Valley Creek, especially in the areas of anadromy in the summer? So if anybody has information about that or wants to help us out, please let me know. I'll put my email in the chat, and I hope to be working closely with state agencies and maybe federal agencies, so think it's a good thing to do, good place to start, and we need to see if we can apply this and inform some of the decision making that's going on. So again, thank you guys so much, and hang in there and keep up the great work.
Thank you, Kimberly. Let's see, I have Nick Jocelyn, your hand's up. Do you have another question or comment, or is that just a lingering hand up?
Sorry, that was a lingering hand.
No problem. Let's see, Chris Milan. Chris, you may still be on mute. Okay, I'm not sure if I can unmute you. I cannot unmute you from here, but it looks like you're still on mute, Chris, if you were trying to speak. You might need to push *6 if you're on your phone. Still not hearing anything, Chris. So if you do have a comment, maybe you could drop it in chat and we could work through there since the audio seems to be having some issues. So let's see here. If there's no other updates, that would bring us to the end of our meeting. At this point, as always, we would take a call for additional meeting topics at our next meeting, which is May 10th. So if anybody has any items, you can feel free to drop them in the chat, or you can always email me in the future. Also, looks like Shay Richardson has her hand up.
Hey, Dan, sorry, I can just drop it in the chat, but can we get NIMPS and CDFW on the agenda for next week for the VDI program?
Yeah, you bet.
Okay, thanks.
So we'll add the VDI update at the next meeting. Any other topics folks would like to try to get on the agenda?
Can I suggest something? This is Conrad.
Yes, Conrad.
As a proposed agenda item, how to create in-stream flow recommendations that result in in-stream flows.
Okay, we can try to figure that out, and we might, for that one, it might be good to know who would be interested in that item so that maybe we could have a sidebar conversation to put that agenda item together, since that's a heavy item. And we would need to figure out who's participating and who's presenting and stuff like that to kind of put it together. So Conrad, would you like to be the lead on that, to can people contact you to kind of put together a side working group, maybe to work on that topic?
Sure, yeah. I just put the agenda item and I'll put my email address in the chat.
Great, thank you. Great, so if you're interested on that item, let's reach out to Conrad and we can set up a separate meeting discussion and try to come up with an agenda item for maybe next meeting or the meet, depending on how long it takes to put it together. We'll get something together. Any other recommendations? All right, that is all we have on our agenda today. So thank you, everybody, and we'll see you next meeting.
Thanks, Dan.
Thank you.
Thank you.
Thank you, Dan.